Hi there, welcome back to this channel. In this video, let us solve these two questions that I set for some of my students recently, and some of them attempted the question and got stuck halfway. So I'm going to be solving the questions, and, you know, I'm sure you're going to benefit from it all. So that's what I'll be sharing. It's all right. So if you have not already, make sure you are subscribed to the channel because I'm going to be posting this sort of content that's going to help you develop your mathematical thinking. Is that okay? All right, let's go to the first one. So let's have solution. The first one says 3 raised to the power x squared minus 7.2x plus 3.2. So let me just separate it. These are solutions. These are questions. So 3.9 minus 9 raised to the power root 3. 9 into bracket root 3 log 7 minus x equals 0. So what disoriented my students was the fact that there were two powers here, and I told them they are even yet to see anything. You see in math, you can have more than two levels of power. Is that okay? Power is for another power is for another power. Is that okay? So you keep evaluating out the powers. You understand? All right. So one thing we could do here is this. So the first thing I want to do, for example, is this. Do you remember the law? If I have log x, log y, x log y base whatever is equal to log of y raised to power x base 10. So meaning that this number here comes to become the power of this y. All right, so I'm going to be using that principle here. So what does that become? So it's going to become log of 7 minus x. So let's put this now in square brackets because it will be raised to this bracket again. 3 raised to the power. So this is raised to the power of 3 raised to the power of x squared minus 7.2x plus 3.9, then minus 9 root 3. So keep in mind that this level, this one and this one are not in the same level. This is a base and this is a power. All of these expressions are power, are 1 power is equal to 0. So this raised to the power of this. So also remember the principle that says that log of y base 10 is equal to 0. This will become what? Or maybe log of x is equal to whatever, maybe equal to m. So this becomes x raised to the power m is equal to y. I told you, if you don't understand this principle of log, I'll link the video on logarithm in the video description so that you can understand what I did here. So x raised to the power m will be equal to what? Y. So from that, using that principle, this will be log raised to the power log, maybe let's put as base 10. We can put any convenient base. Is that okay? So log to base 10 will be raised to the power this will be equal to this. So that we have 10 raised to the power 0 is equal to 7 minus x all raised to the power we brought this here. Okay. So all raised to the power 3 raised to the power x squared minus 7.2x plus 3.9 minus 9 root 3. Yes. You know what? Because the expression is already becoming too big, I'm going to do something because I'm seeing that we're going to be writing this a lot. So let's take b to be equal to this 3 raised by x squared minus 7.2x plus 3.9. So anyway, I put b, that is what I mean. So that this expression becomes 7 minus x all raised to the power b. You know, minus 9 is still there. Minus 9 root 3. All right. Now, minus 9 root 3. All right. So, raised to the power b. Okay, so it's equal to 10 raised to the power 0. And what's 10 raised to the power 0? Any 10 raised to the power 0 is 1. So that we now have, so any 10 raised to the power 0 is 1, right? So we have 7 minus x raised to the power b is equal to 1. So you also know that since n raised to the power 0 is 1, we can also say that 7 raised to the power, 7 minus x all raised to the power b is equal to 7 minus x all raised to the power 0. Do you agree with me? So that with this, we can say that since the bases are equal, the powers must be equal. So that we have b is equal to 0. Are you following along? So b is now equal to 0. Therefore, we can come back to what we made b to be. So b is, we said b was this, right? So that will be 3 raised to the power x squared minus 7.2x plus 3.9 minus 9 root 3. So this our b is equal to 0. Nice. Nice. All right. What more could we do? Let me take this guy to this side so that we have 3x raised to the power. I want to make it simpler for myself again. Okay, there's no need to do that. 3 raised to the power x squared minus 7.2x plus 3.9 is equal to 9 root 3. So from here, what do I have? Let's make everything be in the base of 3. So x raised to the power 2 minus 7.2x plus 3.9 is equal to, now this is 3 raised to the power 2 dot, this is 3 raised to the power half, isn't it? Good. So what does this become? This becomes 3 raised to the power x squared minus 7.2x plus 3.9 is equal to 3 raised to the power 2.5. 2 plus half is 2.5. 2.5 is 2.5. So because we have fractions there, decimals here, let's use decimal here too. So because the bases are now the same, just like we did here, it means that the powers too must be the same. So we have what? X squared minus 7.2x plus 3.9 is equal to what? 2.5. I think we are getting somewhere now. So we can now bring this guy here. Okay, we have utilized this. I mean, it has served its purpose. So let's just clean it off. And we can bring this guy here. Our equation becomes x squared minus 7.2x plus 3.9. Let this guy come in so it becomes quadratic. 2.5 is equal to 0. All right. I mean, it's not because this guy came in that it's quadratic. The power is 2, so the highest power is 2, so that's quadratic. But I'm just saying that's the form, the normal form of quadratic expression. So minus this, minus, oh, there is a plus here. Okay, so let's not make any mistake. Let's check again. X squared minus 7.2. So I think we are correct. So plus this minus this, that is what? That's plus, that's 1, that's 4, that's 1.4. So we have x squared minus 7.2x plus 1. Plus, yes, plus, because it's bigger. 1.4 is equal to 0. All right, so we can solve quadratically. So we look for the multiples of 1.4. The easy way to do this is just take the multiples of 14, which are 14 and 1, 7 and 2. So because it's fractional, let's make one of it a simple fraction that we can use. So we can say 1.4, or no, let's use this one. 0.1 and 14, that will be 1.4. The multiples, the factors of this one, the 7 and 0.2, so I think it's this one that will work because minus a minus is plus minus, so minus minus. So if you minus 7 minus 0.2 will be minus 7.2. And if we times this, we give us 1.4. All right, so we have the correct term for it. So we have x squared minus 7x, so we add x here. Then minus 0.2x plus 1.4 is equal to 0. All right. Good. So from here, we can now factorize. There's a minus here. We can now factorize. So what is common between this and this? X is common. So we factor out x. We have x left minus 7. So let's repeat this. We have x minus 7. So what are we going to multiply with x to give us 0.2? That's just 0.2. Let's return the sign, the minus. I hope you are getting what I'm doing. I hope it's capturing that part. Okay. So the board is broken here. So we have minus 0.2. So it's equal to 0. So we now have that x minus 7 is common between x and minus 0.2, right? So it's equal to 0. So if the product of this gives 0, is either this one is 0 or this one is 0 for them to multiply to give us 0. So it's either x minus 7 is 0 or x minus 0.2 is what? 0. So this one what? X equal to 7 or what? Or 0.2. And that is the answer. Now you can plug in the value of X to check if your answer is correct, and you're going to definitely get 0. So that is how to go about the first question. Now the second question. All right, let's screen this. For the second question, so I think the second question is simpler because it looks shorter. Anyways, that is short doesn't mean it's simple, but it's all simple. I mean, exponential equations are simple. So we have x raised by x minus 2 raised by x equal to 2 raised by x plus 1 minus 6 raised by x plus 1 plus 2 raised by x plus 2. So with this one short thing we can do is let's collect, the way we did the other one, let's collect terms that look alike. So we have 6 raised by x, this guy comes here, plus 6 raised by x plus 1 will be equal to 2 raised by x plus 1 plus 2 raised by x plus 2 raised by x plus 2. So what I basically did was just to collect all the 6's and the 2's together. Alright, so from here, what do we have? So let's break this apart. Let's break everything in full. So we have 6 raised by x plus 6 raised by x dot 6. Because this means times 6, right? Plus 1. Alright. So it's equal to 2 raised by x dot 2 plus 2 raised by x plus 2 raised by x dot 2 squared. That is 4, isn't it? I mean, if you want to express in full. So from here, we have that 6 raised by x is common, right? So 6 raised by x is common between, if you take 6 raised by x here, we have 1 plus 6 raised by x here, 1 times 6, 6 is equal to 2 raised by x is common here, here, and here. So we have 2 raised by x, all right, into bracket, 2 is remaining here plus 1 will be here plus 4 is remaining here. So I think this one is simple. 6 raised by x dot 1 plus 6, 7 is equal to 2 raised by x dot 2 plus 1 plus 7, 2. All right, okay. So this can take care of this. So I have 6 raised by x is equal to 2 raised by x. Oh, okay. So we'll now break this guy up so that we have 2 raised by x dot 3 raised by x is equal to 2 raised by x. All right, so this takes care of this. And we have 3 raised by x is equal to 1. So, and you know 1 is could come from 3 raised by x equal to 3 raised by 0. So since the bases are the same, then the power must be the same. And that is the answer for the second one. So this brings us to the end of the video. If you did gain value, make sure to share the video with your friend that you know might benefit from this video. And if you have any question on exponentials and indices, you can drop them in the comment section and give the video a thumbs up and comment, basically. So God bless you as you do so. Amen.